Bonjour. There's more. Je m'appelle Trisha. J'habite en Espagne. Je ne parle pas français. I do speak Spanish, but I don't speak a lot of French. I've followed enough to vaguely follow what Louis was saying, which is quite helpful. But I am going to talk about developer productivity engineering. I will try and speak a bit slower than I normally do, because I speak really quickly, I'm sorry. Yes, I am Trisha. I am a lead developer advocate at Gradle, Java champion, still part of the JetBrains community, a JetBrains community contributor, because I wrote a book about IntelliJ. Please buy my book. If you go to the QR code, I'll give you a minute, there's a chance to win a book. Where is it? Thank you. I had to pick one of these books, and I figured that I would bring 97 things every Java programmer should know. But now I'm thinking maybe I should have brought the IntelliJ book, because people seem kind of keen on that. So buy that one instead. Now I've got nowhere to put this. Okay, so at the end, I will try and remember. Someone remind me, and I'll try and remember to do the draw and pick someone's name. I will probably horribly mispronounce your name, but you might win a book, so it's worth it. Okay, so today I'm going to talk to you about developer productivity. The reason why I kind of mention a lot of these things is because over the past 20 odd years, what ties together my career is an interest in developer productivity. Not from the point of view of, let's get more lines of code out of developers. No, from the point of view of a developer who enjoys doing what they like, what they do. Coding is supposed to be fun. It used to be fun when we first got into it. And you imagine you're just telling the computer, you've just written your first Hello World app, and you're like, yes, it works. It did what I told it to do. But like, how often does the computer tell you do what you told it to do? Now imagine the kids have to wait 20 minutes for their build to finish in order to get the Hello World app. And this is much closer to the reality of our jobs as developers, more often than not. So the developer joy has somewhat leaked out of our daily existence. So this is a not very typical developer's calendar. Imagine you get a whole hour and a half to write code in the morning, which is like bliss in my world. You write the code, and then you wait for some time for your local build, and then you spend an hour debugging some sort of build failure, and then you have lunch, which is a good thing, and then you write some more code, and then you're still waiting for these things, and then maybe it works and you commit it to CI, and then you spend an hour waiting for CI to finish, and then you have to investigate some test failure, which may or may not have been your problem. And by the end of this day, this glorious day which had no meetings in it, you've spent very little time coding, relatively speaking. And in fact, of course, as you all know, it gets much worse than that. Because according to this Tidelift survey in 2019, developers spend about 32% of their time writing code. They don't get these glorious days of writing code. Who thinks they spend more than 32% of their time writing code? Right, you are the luckiest person in this room. Who thinks they spend less than 32% of their time writing code? Like literally everyone. Well, everyone who didn't put their hands up is in marketing and doesn't write code. That's me, by the way. So the reality is we don't have a lot of time to write code. I'm a big fan of this other. Like, I don't know what that is, but my other is about 99% of the time. We don't, yep.
There's no time for reading code?
I've got to admit that this is a bit of a weird thing, because I'm glossing over the fact that it puts testing separate to writing code. It's supposed to be the same thing. And I would also argue code maintenance is also code. But I'm assuming code maintenance means Docker didn't work and I didn't know how to fix it. Other. Okay, so we don't have a lot of time to write code, and we really want to make the most out of that time to get this developer joy and not be waiting for builds and debugging flaky tests and so forth. There's a quote from some guy from Dell Technologies, and he says, bottlenecks in the tool chain are holding back the rockstar 10x developers. I think maybe you're getting a sense of what I feel about rockstar 10x developers. I do feel they're about as easy to find as unicorns in El Chupacabra. In all my years working, I've worked with some very effective engineers, but I'm not sure I've ever worked with a single engineer who's 10 times more effective than everyone else on the team. There are good engineers, but where did the 10x engineer myth come from? There was a book in the 70s, 80s. It was a long time ago. It was around about the same time I was born. And in this book, they were doing a study on what makes developers effective. And they were running this thing called coding wars, and they were pitting two developers against each other to sort of figure out who are the best and what are the things which makes a good developer. And they found that the best programmers outperformed the worst by a roughly 10-to-1 ratio, which might be where this 10x engineer idea comes from. However, it's a bit more complicated than that. What they found is that the two programmers who were competing against each other to complete some task performed at roughly the same level. This is kind of weird because they're not collaborating on a task, they're competing. So, well, yeah, just that. They didn't work together on the task. They came from the same organization. So the thing which made the two developers more similar or defined their level was the fact they worked in the same organization. This is really relevant because they were working in their normal office environment when they were completing this task. So they had their normal office space, their normal phones, their normal interruptions and meetings, and all the stuff that normally goes on when they're writing code. So developers from the same organization performed at more or less the same level. However, the best organizations performed 10 times better than the worst organizations. So there's not really such a thing as a 10x engineer. There is such a thing as a 10x organization that makes developers more effective. So what mattered in this thing, in the coding wars? The first quartile organizations provided more space for their developers, had more quiet, more privacy, they could silence their phone. I don't even know who would want to do that these days. Divert their calls. This is obviously in the 70s and 80s. And the highest performers got interrupted a lot less than the worst performers. So it's all of these things that make a developer effective. It's not necessarily some innate development experience. And so this is all down to developer experience. Now, back in the 70s and 80s, we weren't calling it developer experience, but this is what the developer experience is, the environment we have to write our code. And they summarized it with, the bold fact is that many companies provide developers with a workplace that is so crowded, noisy, and interruptive as to fill their days with frustration. That alone could explain reduced efficiency as well as a tendency for good people to migrate elsewhere. There's actually two things going on. One, you have an environment which is difficult to work in because it's interruptive and noisy. And two, your best developers who have any choice in where they work will leave. So if you have a poor environment, it will just end up getting poorer over time. You need to be able to provide that environment for developers. Now, what has this got to do with DPE, Developer Productivity Engineering? DPE is a software development practice used by leading software development organizations to maximize developer productivity and happiness. It's really only the happiness I care about because, like, you know, I'm a developer. But what does it mean? What problems is DPE solving? It's solving things that take too long to fix, and things that should not have been broken in the first place. Now, for every individual developer, imagine they're surrounded. You don't have to imagine, this is your life. You're surrounded by stuff that takes too long, that is difficult to fix, that shouldn't have broken in the first place. Now, you multiply that by the number of days in the year, the number of developers in the organization, and you find that in the organizations that have more of this rubbish, you've got lower productivity and a much more increased cost. So all of these things that we tend to think of as small frustrations, slow build times, or tools that don't work properly for us, are actually costing our organization a lot more money than they realize. So we think that DPE kind of fits in on the end of all of these other change things which have been going on over the years. So just-in-time manufacturing, business process re-engineering. I worked for Ford Motor Company when they called it process re-engineering at the end of the 90s. Agile, Lean Six Sigma, DevOps. And so off the back of all of this, the sort of next movement is DPE. If you like, you could also call this developer experience or platform engineering. It's all kind of in a similar sort of space. There's subtle differences, but this is what we're talking about here. So although like DevOps and Agile and so on, they have made a lot of progress for software engineering over the last few decades, but they've not captured all the bottlenecks, friction and obstacles to throughput. And a lot of them are hiding in plain sight in the things which frustrate you every day in your jobs, but they haven't been exposed yet. So, a 10x organization needs to be reducing build and test feedback times, helping developers to troubleshoot problems, and improving the consistency and reliability of builds. Now, I think we're starting to get to the point where you understand where Gradle comes in, because we use the word builds. Builds is a good thing. So let's look at some of these pain points, some of these little pains that annoy us every day as developers that add up to big problems. The first one is waiting for builds and tests to complete. Like, is anyone here tracking how long it takes their local build to run? Wow, this is great. Like 2 years ago, there would have been no one in this room who did that. Well, still not everyone, but like, it's a good thing to track to see how long it takes to do a local build. Oh, so let's talk about local builds. Whose local builds take longer than 20 minutes? Okay, yeah, all right, not surprised. I'm thinking builds and tests, by the way, but you don't necessarily, more or less. Build and test, everyone. Okay, tests as well. Between 10 and 20 minutes. Okay, between 5 and 10 minutes. Less than 5 minutes. Nice. Okay, you don't need to be in this talk. You can go. It's fine. No, it's not true. You can stay here. So tracking local build and test time. This is really interesting because if you look at DevOps and if you look at, Agile, but DevOps in particular, the focus is on CI. How long does continuous integration take? How long does it take to get from the commit into production? We haven't stepped back and looked at the local development environment because it's quite difficult to test those sorts of things. I'll come back to it. There's a book called The Goal, which talks about the theory of constraints. And in The Goal, it says, the only initiatives that will positively impact performance are ones which will increase throughput whilst simultaneously decreasing cost. Now, this is important, particularly when tech companies are laying off developers because they think it's going to make them cost effective. When you lay people off, you decrease your cost, but you decrease your throughput, like nothing's going to happen. If you really want to improve the productivity and effectiveness of an organization, you need to be improving the throughput, getting more stuff through to production, which means we need faster feedback. We need to be doing stuff faster. I'll give you an example. These are 2 teams that were customers of Gradle. The first team has 11 people. Their build time is 4 minutes, which in my book is pretty good. And so in a week, they run 850 local builds. The second team is half the size. Their build time is 1 minute, and they can run over 1,000 builds in a week. So with fewer people, but a much, much shorter build time, their throughput is much, much better. So they can get more, they can run more experiments. They can prove more quickly that they're doing what they think they're doing, that their code works properly. And the reason why fast feedback is important is lots of things. You can't see it that well on this, but I'll just read it out to you, it'll be fine. So if you've got faster feedback cycles, you ultimately end up with better quality and higher productivity. The faster feedback cycles means you can build more often. Sorry, I'm not allowed to move. You can build more often, which means you get smaller change sets, which makes it easier to find any problems, and you get fewer merge conflicts, faster mean time to recovery, because I can never remember what that is, which leads to better quality and higher productivity. Also, if you build more often, you find problems earlier, which means you fix things faster and it's cheaper to fix problems, which means higher quality. And if you have faster feedback cycles, you have less idle time waiting for stuff to happen, less context switching. Context switching is a killer. It's not the waiting around, it's going to another task, and then the build fails, and then going back and going, what was this? It absolutely kills you. So less context switching, more focused developers, which is better quality and higher productivity. There are literally no downsides to having faster feedback. It's good across the board. So how do we get faster feedback from our builds? The solution is acceleration technologies, and actually Louis already talked a little bit about this, so he stole the thunder from my talk. So I was understanding what you were saying. So there's a number of acceleration technologies that we talk about from Gradle and Develocity. We've got the build cache, predicted test selection, test distribution, performance continuity, and I will go through all of those. The first one is the build cache, which I don't need to talk about, thanks very much. Sorry. That's fine, it means I don't have to talk so long. So the build cache is going to speed up your builds and tests. As it was mentioned, as with any cache, if the inputs are the same, your outputs should be the same. So you cache whatever your Gradle task was or your Maven goal was, you cache them so that when you rerun that task or goal, then you can just get the results from the cache. So if nothing has changed, then you don't have to build. So you get a much faster build time. I can do a very short demo. I was missing doing stuff on IntelliJ, so let's do a very small demo. If I can get it to work. Where are we? Mirror. Okay, zoom. Whoa. Okay, not that much. So, with this project, it's Morphia. It's an open source project. If you run it without a build cache, it takes 4 minutes and 32 seconds. It runs a whole bunch of stuff against MongoDB, using test containers and so forth. And then if we enable the build cache, it's supposed to be fast enough that this demo is not really boring. That's the plan. Let's see if it works. If it takes 4 minutes and 26 seconds, it's going to be extremely boring. So we should be able to see somewhere along here, it says loading from cache, but it goes up so quickly you can't see. But anyway, as it runs each of these goals, it's going to the cache to see if it's there. There we go, loading from the build cache. It doesn't have to rerun the build, it just gets it from the build cache. And then it can run the whole build in 27 seconds instead of 4 minutes and 20 seconds. So, you know, and this is a genuine Maven project that I've actually run this on, the Develocity build cache. So you get some really good, and that project hasn't been tuned either, so you get some really good results from that. Sorry, I need to get my notes back up. We need displays. Now I remember why I don't do demos. Okay. And as another example, when the Spring Boot project started using Develocity's cache, then they went from a 20-minute build time down to 3 minutes without even tuning any of the caching. And potentially, they can bring the build times down even further, but like, you might not even need to. You might be fine with a 3-minute build time. So Develocity's, so did I even mention, yeah, I don't know, you probably did. Develocity, another product from Gradle. Used to be called Gradle Enterprise, but we called it Develocity because it supports Gradle, Maven, SPT, and Bazel. So it's not just a Gradle thing. So the project I just showed you was a Maven project. This Spring Boot has the Spring projects are Maven and Gradle. So I showed you the local build cache, but what's really interesting is when we talk about the remote build cache, which also Louis mentioned. So with a remote build cache, there's an environment which is always building your code, is always building the project, right? And it's called CI. So when CI builds something, you really want it to put the results of that into the remote build cache. Because then when you get that commit from Git or whatever, you don't have to rebuild the whole thing. You just get it from the remote cache because CI has already built that. So I don't have to do my 20-minute build, I'll just have CI do that and get it from the remote cache. So the remote build cache is really useful. And imagine if your team is 20 people, 100 people, and they're all benefiting from this remote cache and not having to rebuild every single time, you're getting back a lot of time for your developers every single day, or at least every week. So that's the build cache. The next thing I want to look at is test distribution, which is going parallel. So test distribution parallelizes your test execution. Build caching is fine if nothing's changed, but if nothing's changed, you don't need to build anything. If you have made some changes, which is what we do every day when we're coding, then the build cache isn't going to help you because the inputs have changed. So what you probably want to do is you probably want to run your build in parallel, which interestingly, this demo is running Groovy, the build for Groovy, the language, and you can see all of my CPU cores are being taken up because Gradle's running it like massively, well, not massively parallel. Gradle's running it in parallel on my machine. Lots of people don't realize you can actually run Maven builds in parallel as well. So you can go parallel locally. But single machine parallelism is limited by that machine's resources. I can only go as parallel as the number of cores, that are CPU cores on my machine. Another alternative is to use the cloud. Your CI environment's probably in cloud or somewhere out there that's not on your local machine. And CI tends to go very parallel as well. But the CI solution is a little bit different too. Often, you end up having to sort of set it up manually and figure out how you're going to partition your build. And it doesn't help you when you're doing local development because it's CI, so that doesn't really fix your problem. So this is where test distribution comes in. Test distribution is something that sits somewhere that when you run your local build or the CI build runs, it can split up your build and run it on multiple agents. So Develocity does have test distribution, and you can set this up. I actually worked for a place where we built our own test distribution, which is possible because JUnit's kind of designed for you to look at all the tests and just dish it out over different agents. But then you're going to have to build and maintain your own distributed system, which you probably don't want to do. You probably want to buy something that does that. But then it means that your local environments and your CI environments are all benefiting from having this test distributor, and you can go massively parallel, as many agents as you want. And it doesn't matter where you run your build. And you tend to find that as you double the number of agents, you halve the amount of time it takes to run your builds and tests, up to a point where you probably don't need more agents because you can't split it down any further. And Netflix found when they were using Develocity that they could get their 62-minute test cycle time down to just under 5 minutes. So that's a big deal. So anyone who thinks that their tests take too long to run, which is a thing, the answer is you might just want to run them very, very parallel. I'll let you finish. I don't have enough to say while you're taking photos of the QR code. So that's test distribution. The next thing I want to talk about is predictive test selection. I want to talk about predictive test selection because you can't give a talk without mentioning AI these days. It's illegal. You have to mention AI. Technically, what we're doing is machine learning, but that's not the point. There's a paper from Meta a few years ago where what they wanted to do is they've got a big monolith, and they figured, like, why, if I change 3 lines of code, do I have to run all of my tests from the whole monolith in order to check that my 3 lines of code work? There must be a way of only running the tests that are important for those 3 lines of code. And they did a few different things to try and figure out how to figure out which tests are the important tests. They came up with a machine learning algorithm which will do it for you. So it will figure out for certain changes which are the tests which are most useful for those changes. So we took this, and obviously we made it better, and we put it into Develocity. It's going to work. This is a pretty picture. I'm not sure how informative it is, but it looks cool, so it's on here. And we put it on the website. The idea is that you're always running your tests in CI. So you can train the model on CI even if you're not using all of predictive test selection. And it will look at all of the changes that go in, and it will look at all the tests and the test history and which ones passes, and it will learn from that. And so you can, when you turn it on, you can say, well, I'm only going to run these tests. I'm not going to run all of the tests. And it will continue to learn based on the tests that are running in your CI environment. It will continually retrain itself. Now, when you use all of those things together, you can really reduce your build and test times. The build cache stops you from having to run builds that you don't need to run. Predictive test selection will allow you to select a subset of your tests. So you only need to run maybe 30% of your tests. Then you're going to use test distribution to distribute those over parallel agents, so that way you can run those much faster as well. And the final piece is performance continuity, where you actually need to have a look at the performance of your build to figure out, is it good, is it getting worse, is it getting better? And you want to keep doing this cycle again and again. So I remember being on a development team where we were asked, is the build and test cycle fast enough? And generally, when you're asked that question, you go, yeah, well, you know, sure. But it's the wrong question. And the question should be, is the build and test cycle as fast as it can possibly be? I mean, the answer is always going to be no, but that's where you should be driving. Could it be faster? Yes. What can we do to make it faster? Is it important? Yes. It increases productivity and decreases cost. It's not just a small niggle, which is a problem for us. It has business benefit to bring the test and build cycle down to something much more manageable. So, the second pain point, inefficient troubleshooting of broken builds. So, I don't know about your teams, but most teams I've worked on, when there's a problem with the Gradle build or the Maven build, and you as a developer don't know what it is, which is 90% of the time, there's like one person on the team who you go to go, dear Charles, my build doesn't work, I need you to look at it. Right? And it's quite difficult to debug broken builds. So the build scan that Louis was showing earlier, this is quite a good way to show that person or the people who work in CI or the platform engineering team the build that you had that broke and that you don't know what's wrong with it. Because it includes things like the infrastructure information and all the information about how the build ran. Without this kind of information, if the build fails on your machine, it's quite difficult to kind of take your machine to someone else if you work remotely and say, the build broke, can you fix it? Right? You need some way of sharing that information. And the build scan's cool as well because you can actually link to specific parts of it and say, look, I think this dependency is suspect and I need some help with it. Where the power really comes in, particularly with something like Develocity, is that build scans are cool. But imagine if you're collecting a build scan for every build that you run in your organization, in CI and locally. You can pull together that information to go, you know what? All of these people had the same problem as you in the last week. There's probably something going on there that we need to fix. The builds all failed for some reason, some specific reason, and we can actually target those failures and do something about it. So we can prioritize problems and fix them in order. Next pain point, flaky tests and unreliable builds. Flaky tests, it's my least favorite thing. I actually joined Gradle because I learned that we can detect flaky tests in Develocity. And it's something that I've been going on about for about 15 years and no one else seems to care. Flaky tests drive me crazy. You spend all this time, you've written automated tests, which makes you like infinitely better than all the other developers out there. You actually wrote some automated tests. You run them in CI, they pass, and then sometimes they don't pass. And then they pass again, but then they don't pass. And then you're like, okay, I don't really know what's going on here. I have a test which it's not telling me nothing, it's actually actively getting in the way of any information because it's failing and I don't know why. And so usually what happens, when it's flaky, I don't really know why it's flaky, so I just keep rerunning it until I just give up and just submit the PR anyway. Flaky tests are really toxic. They are absorbing our time and energy. They're spending energy in CI, running and rerunning, and they make us doubt the quality of our tests. When tests start failing, we're like, well, maybe it's one of those flaky ones. And we just ignore it. So there was actually a study done on this. It said, our analysis revealed that rerunning the failing build and attempting to repair the flaky tests were the most common actions. I think the people who said they attempted to repair the flaky tests were lying, because I generally don't see that. But rerunning is definitely the most common action. Our findings also suggested that developers who experience flaky tests more often are more likely to take no action in response to them. And that's why flaky tests are so bad. As soon as you start having a lot of flaky tests, where a lot is probably more than 3, you're going to start ignoring tests that fail. And you're going to start ignoring tests which are actually failing. So then there's no point in writing tests because you're not paying attention to the results. So you want to identify and track flaky tests. So Develocity does this. You can see for like all of the builds over the last month, you can see these are builds that failed. And these are builds that had flaky tests in. So we can see this is I think this is Spring Boot actually. We can see that their number of flaky tests is going down because they actually actively work on fixing their flaky tests. And then when it goes up again, they can do something about it. And you can order them by how flaky they are. So you can find the most flaky test, which is super cool. And it does this by rerunning failed tests, which I'm not super happy about. But if in the same build a test fails and then you rerun it and it passes, then by definition you know that's a flaky test. It's the same test on the same code in the same environment. So you can use retries to determine whether your test is flaky or not. However, don't use this as a fix. I was talking to someone else, who was I talking to, like in this last week, who said that once they implemented the retries mechanism, all their flaky tests went away. No, they didn't. You just started ignoring them a lot more. So you do need to then, once you've identified them, put aside some time to fix them. Now, Dave Farley, who's my old boss, who wrote the Continuous Delivery book, he did a video on the Continuous Delivery YouTube channel about the 5 causes of test intermittency. So have a look at that. It talks about some really good things to look at. Things like date and time is awful, and asynchronous calls, and anything which involves waits. And then the 5th cause is something's broken in your production system. So when I worked with Dave, we had a tool called AutoTrish, based on me, that found flaky tests. And we managed to get rid of a lot of our flaky tests, and then a whole bunch of them were still failing. And we couldn't figure out what the problem was. And it turned out it's because we had a race condition in our production code. It was a financial system. It's a really good thing we took our flaky tests seriously, because we found that problem before we lost someone millions of dollars. It was great. So I wrote a bunch of blogs about finding and fixing flaky tests. There will be a QR code at the end of the thing, which will have a link to a page which has all of these things in. I really hate flaky tests, I just do. All right, next pain point, no observability or metrics. So you've done all of this work accelerating your build and test cycle, you're using a build cache, you've tuned it, and you've found all your flaky tests. But if you don't stay on top of it and do this continually, which sounds kind of painful, problems are going to sneak back in. And this is entropy. This is how physics works. I mean, if you go into your children's bedroom about 1 day after they tidied it, or 10 minutes after they tidied it, it's already a mess. And that's what it's like with life. So if we don't keep an eye on our build system and our build times and our test times, things will just start to creep back to a not so great place. So if you aren't improving something, things are getting worse. That's what physics tells us. So it helps to know what to improve. In Develocity, we're tracking all these kinds of trends about build time, build failures, and things like that. So if you start to see a trend like this, you can be like, well, perhaps we should do something about what's happening with the build time there. The one last point I want to leave you with on this section is a quote from Mike Nygaard's Release It book. And he says, the tools, services, and environments that developers need to do their jobs should be treated with production-level SLAs. The development platform is the production environment for the job of creating software. Now, I've worked in a lot of places where developer machines are less than optimal. The staging environment is an absolute mess. The test environments are just like whatever was left over, and we didn't have any resources, so there you go, have a laptop for running tests on. But the code goes through all of those environments to go to production. And this is the code we use to take care of people's money, or like get people's money from them to us. It's really important that the systems we use to get our code to production are treated with the same respect as production is. So we should be observing them, we should be monitoring them, we should be accelerating them, and we should be resourcing them correctly. Next pain point, inefficient use of CI resources. When I first saw all this stuff about acceleration and bringing down build times and bringing down test times, I automatically assumed that it would reduce the cloud bill of your CI environment. And this might be the case because you might be spending less time running CI builds and so forth. But generally what many of our customers have found is that they still use the same amount of resources, they just run way more builds. They just are much more efficient with that time. So you might not see a decrease in cost, but you will see that the utilization is much more efficient. So you're getting much more for your money in your CI environments. So, in summary, 10x developers might be a myth, but 10x organizations are real. They can be measured, and we do know what makes an organization more effective for developers. Developer productivity is deeply linked to developer experience. It is about having uninterrupted time. It is about reducing context switching. It is about being given the headspace to do our jobs properly. If you do nothing about productivity, life will get worse. That's just entropy. Fast feedback, efficient troubleshooting, and reliable cycles are key. Start with observation, then take action on data. So I've given you a whole bunch of solutions, and you might be going back to your workplace like with your head buzzing with all these different things. The first thing you probably want to do is measure something. Measure your local build time, measure how long your queues are in CI. Whatever it is that you think might be a problem, start by measuring things and then figure out what you need to optimize, like any performance problem. Proactively solve problems for the whole team. This is what I really like about DPE. If you can reduce the build time from 10 minutes to 5 minutes, you haven't just done it for you, you've done it for the whole team. You've got this force multiplier. Now every developer in that team benefits from that one change. It just has a huge impact across the organization. And DPE fosters developer joy. A bunch of surveyed users who happen to be our customers think that DPE brings them joy. It's not just about productivity, and it's not just about, you know, doing more for the business. It actually just makes their job more enjoyable because we don't have so much frustration and toil. But if you do need to sell it to the business, because you always need to sell it to someone at some point, the fast feedback cycles actually just affects everything that the C-level folks care about. So if you can reduce slow builds and slow feedback cycles, you get faster delivery, which means more revenue. You get more productivity, which is resource efficiency and decreases cost. If you can fix inefficient troubleshooting, testing, and CI, again, you get resource efficiency, decreased cost. You can get better quality and a better brand image. So again, like, no downsides here. This all translates to stuff that the business really cares about. So on that note, thank you very much. I'm going to try and draw the book winner. If people, did everyone get to put their name in who wanted to do that? And then you can ask questions. Let me just see if I've got it somewhere. Or you can try and ask me questions while I do this at the same time. Oh no, you have to ask me questions first because I'm not connected to the internet. This isn't going to work. Any questions? Yes.
I have a question regarding the predictive test selection.
Yes.
How the model is aware that all the modified code will be effectively executed, all the tests that are related to the code that was modified, because sometimes you can modify a local code, but it can have a big impact.
Yes.
So how do you make sure that all those tests are really executed?
Yes. So there's two things I want to answer there. One, predictive test selection selects the test based on which tests have failed in the past when these lines of code have been changed. So it's really, when it talks about the most valuable tests, it means the tests most likely to fail if something's wrong. So firstly, yes, it's based on a history of these lines of code often lead to these tests failing. And there might be a cluster, which is an interesting thing too. And the other thing is Develocity's predictive test selection has 3 levels that you can pick. It's got like fast mode, which will pick a smaller number of tests. You will run this generally on your local environment, so it will pick a smaller number of tests, but with like less certainty that it picks all the tests which are going to affect your code. Fast mode, medium mode, and then like a high quality mode where you're probably going to pick all the tests which are relevant, but it'll take longer to run. The important thing about predictive test selection is you probably mostly want to run it on your machine. So it's to give you a sanity check that you didn't break anything. But on your release branch, somewhere on CI, you will run all of your tests, because otherwise, yeah, you don't know, you might have missed something. Does that answer your question?
Yeah.
Okay, cool.
in addition, the fact that you have that CI branch where you run everything, then that populates the history. Because if a test was missed and then actually fails, then the model learns that. And so can reuse that information for the next execution. So like, it is critical to run everything.
Any other questions? Yes?
About the test distribution, would it work with the instrumented test like on Android?
Would test distribution work with instrumented tests on Android? I don't know the answer to that question. Test distribution works on any JUnit-based test framework, which includes things like Spock, and it runs on TestNG as well. But other than that, I'm not sure about the ins and outs. Yeah.
Question about that. What do you do about third-party services that are needed for integration testing? When you distribute, are you able to reuse some infrastructure resources?
Right, that's a good question. So when you're distributing, if you need other things, what are you going to do? So here's one of the things about test distribution. Test distribution relies on you having written tests which can be parallelized and can be run independently. So if you've got things like test containers, for example, which are going to start everything up that you need and you know that they can run wherever, then that's going to work really well with test distribution. If, however, you have like one third-party endpoint or something that all of your tests are going to end up attacking at the same time when you run them massively parallel, then you might run into some problems with running stuff with test distribution. Also, if you're running in the kinds of environments where you need a lot of manual stuff set up on the agents to begin with, it's also not going to work very well either. Test distribution works best if you've got all of the sort of classic CI/CD automation, you can start everything up from scratch, and everything is fully isolated. So, I mean, the answer is it depends, but you generally want everything to be as automated as possible. However, there is a performance hit of that, right? Because if you run everything in one environment, but you have everything you need in one environment, then you don't have a lot of time in starting everything up. If you run everything parallelly, each agent is going to have to start everything up. So when you add up all the times, it will potentially come to more time. So there's a lot of trade-offs. I mean, this is classic distributed/parallel computing, right? It's just trade-offs. Yep.
Yeah. So on that one, is there a general for the setup of the agents themselves? Is this generally like just something you would have in a Docker container, or something that would be run as a persistent kube host or something, or a kube pod?
I don't know, but I know Kubernetes generally comes into these things. Do you know the answer to that?
Not in detail.
No, I don't know.
No worries.
Sorry. I can find out, but I don't know.
Yeah, I was wondering if you had other examples of useful things to parallelize in a build besides tests.
So generally, in one of my other tests, in one of my other talks, which is about testing, I have a breakdown of build times from several of our customers. Generally speaking, in a build, tests will take at least 60% of the time of the build, if not up to 90% of the build. So that's why generally a lot of the parallelism is around tests, because testing is what takes the time in your build and test cycle. But like, I mean, when you're running Gradle in parallel, it's running everything in parallel, right? Not just the tests. And same with Maven, I think. Actually, I don't know about Maven. So you can, and actually when you run Gradle in parallel, the tests are just one thing, aren't they? No, they get run in parallel as well. It's Maven that can't always do that.
There are different levels of parallelism.
Yeah. So if you're running Gradle in parallel locally, then it will parallelize everything, but it won't do it over the test distribution agents. But the main benefit is in the testing, because the testing is the thing that takes the time.
I actually just thought of it. So I know that there's some extensions, compatibilities with some other languages like Python and NPM.
Yeah.
Is this something that is planned to be extended into those languages? And are there like hooks that you could use, say, if I wanted to write it for another language as well?
So, yes, we would like to support everything. We would like to support everything. We are doing NPM and Python for build scripts, scans, caching. The idea is to try and provide as much as possible, but a lot of these things don't have build tools per se, like Gradle, so they don't work the same way.
Right.
So we can't always provide the same sort of functionality. But the idea is that the reason why this comes under a DPE heading rather than Develocity heading is that you should be able to do this for any language, for any tool chain. And we would like to be able to do that.
Okay.
I don't know how hard it is.
That's what we're trying to figure out as well. So.
Right.
I'm waiting for the microphone.
Okay.
I would like to know which language have you used to create Develocity?
I saw Java. Oh, Kotlin. Java?
Mostly Java.
Would be Java, right? God, now I look like I'm
It's
not.
vanilla Java or with a framework?
There's, God, I feel like I should know the answer to that question.
Okay.
I don't know the answer to that question,
Okay.
but they're all Java
No
folks.
Okay.
I don't know. I should ask them.
Okay. Thanks.
God, I've said I don't know a lot of times. Don't know the answer to that question. You have to get back to me.
About Develocity, what about the pricing and business model? Is it per dev, per org, per build, per?
Yes. There is a per user pricing model, per seat pricing model, but there's also, we recognize that there are certain use cases, like if you only wanted to use it in CI, when you can't do like a per seat model. So pricing is something that we are constantly looking at to make sure that we can provide something that's cost effective for lots of organizations. At the moment, it's like per developer.
Do you have plans or ideas to solve the issue of using a daemon in a CI environment?
Oh, that's definitely a Louis question.
So what kind of issue in particular?
The benefit from having a daemon which is hot.
Yeah, so, okay.
Cold when you start your CI job.
Yeah, so if you have effectively ephemeral CI environment, then you don't get the benefits of the hot daemon, but you still get you still get that as an execution environment that you can then configure memory and things like that. But yeah.
For now, yes, but do you have ideas to, I don't know, to benefit from the capturing the JVM optimizations done from one daemon and maybe reuse that and maybe have a daemon that is hot already?
You can share your daemon from your daemon, keep it as things.
Yeah, but so the comment from Charlie is that you can share it. You can't really, but it's true that there are no techniques about like keeping the optimized state of the VM and restoring that. It's not something we've looked at. Yeah. Like it's the same. We've looked at a bit at GraalVM, for example, as a way to make the launcher independent. But it's complicated because we do reflection and stuff that we shouldn't do for GraalVM optimization. So, but stuff might be coming. So yeah, it's yeah, evolution on both ends.
I have drawn the winner of the book, and it was someone whose name I can't pronounce. Loic Levloch. There you go. You've won a book. Congratulations. You're very welcome. Any more questions? Then I think we can wrap this up. Thank you very much.